Hello. In this video, we'll give you a quick introduction to clustering and partitioning so that you can decrease the cost and increase the performance of your BigQuery queries. To kick things off, I'm going to seed some fake data into a table in BigQuery that we can use to demonstrate some concepts. This simply loads about 10 million records of random data into a BigQuery table, and we just need to create the dataset before we're able to run that. So, in the BigQuery interface, I will create an events dataset, and then we'll be able to run our data ingestion script. We will provide this script in the description of this video. Make sure that you've already authenticated your G-Cloud CLI so that this script will have an authenticated connection to Google Cloud and BigQuery. Now, I happen to know that with about 10 million records, we're going to have about 300 megabytes worth of data, which is neither huge nor insignificant. Our Python script is first going to generate that data and then stream it into BigQuery. So, if we give it just a minute here, we'll have a fresh table that we can use to demonstrate some of these concepts. With that, we have our data loaded into BigQuery, 10 million rows. Let's go ahead and check out the console. Here we have the schema that it's picked up on, and then in the details, we can see that we have 10 million records, taking up about a third of gigabyte of storage. Now, let's explore this data a little bit and look at the cost and performance. If we were to query this table and grab all the data, then we're going to end up having to scan and also pay for that full 1/3 of a gigabyte of data. However, we can select certain columns to be able to bring down both that cost and bring up the performance a little bit. In any case, let's go ahead and see how long a query takes when we grab all the data and all the columns. All right, so we got our 10 million records in about 8 seconds or so and consumed about 1 minute, 10 seconds of slot time. Note that the slot time here is really a measure of the processing capacity that was applied to a query. There are ways to select only the columns that we need in order to limit the cost and improve the performance. However, fundamentally, without partitioning or clustering, we're going to be doing operations over a really large number of rows. Even if we have a where clause, our query has to check every record to see if it matches, and in doing so, we get maximum query times and query costs. This is really important to remember. So let's contrast that with an approach that uses clustering and partitioning, and we'll talk about both of these concepts. Let's delete our table so that we can recreate it, and then we'll update our script to use the clustering and partitioning. By bringing in that new code, we're really only changing a couple of very small things here. First, we're setting up partitioning by using the date time field in our table. Now, this doesn't have to be time-based partitioning. There are other supported data types. But we'll imagine that we're just going to be querying the most recent data for this event log, and we don't need to be checking old, historic data in those queries. We don't want to pay for that old data in terms of query performance and processing costs. Similarly, we're going to use clustering on the system field to be able to further optimize our queries that have a where clause specifying a specific system. A graphic in the Google Cloud documentation can be pretty helpful for understanding these two concepts. So if we look at this example, we've got a table, and this is not clustered or partitioned like we had in our first test. When we apply clustering, that means we're going to order the table based on the fields that we provide. For example, this is clustered by country, so you see the country groupings all within this table. We can layer on partitioning to have separate sets of data based on, in this case, the order date, and we're splitting that by day. That way, if we need to get the orders for just today, we don't need to check the partitions for other days. Now, you can have partitioning, you can have clustering, you can have both, or you can have none. There are really 4 separate options here. And there are some documented best practices on how to approach these. For example, you typically don't want to partition unless each partition has at least about a gigabyte worth of data. In our case, we're not actually following that rule, but we'll check on the performance and cost implications anyway. So now let's actually run that data ingestion with the new clustering and partitioning. As before, we'll need to wait just a couple of minutes for the data to load and our 10 million records to be in place. Now that the data has been inserted, let's go ahead and check out the table in BigQuery. So now, when we go to the details, even with this banner on the top, we see that we've got some partitioning in play. We've also got clustering. Remember that we can cluster by multiple fields. For example, we can first sort by system and then sort by event type and so on in our queries. We can match that in our clustering and potentially gain even more performance and cost advantages. We've got about 325 megabytes of data and 10 million rows, and note that we decided to partition by year since we don't have a ton of data and the data spans about 3 years, so we've got about 3 separate partitions. Before we start to investigate this table and check out the performance, I do want to make sure that we're playing fair here by turning off caching so that we get nice comparative results each time. So, as before, if we're going to get all the data, that's going to be about the same amount of time and processing as before. Now, we did get a little bit faster ellipse time and slot time consumed. Originally, we had 8 seconds elapsed time and a minute and 10 seconds of slot time, so it was about 50% faster. Before, we had about 1.4 gigabytes shuffled, which is now 1.04. However, what gets really interesting is if we change this and start doing things like, for example, querying based on the year. So, if we add a where clause here to get all records where the year is 2023, note that we actually get this query validator that suggests how much data we're going to be processing, which is going to be very tightly connected to costs. We can see that only about a tenth of the data actually needs to be read for this select query, and so we're only going to be paying for about a tenth of the query cost. If I run this query, we can also check the performance, and we see that it gave us our fastest query yet at just 2 seconds of elapsed time and only 4 seconds of slot time consumed. That's quite the comparison to the minute and 10 seconds of slot time we had for our original select all query and the 40 seconds of time we had for our select all query with the partitioning and clustering. We simply don't need to check as much data when we're running this query, and that's going to save us a lot of time and money. Now, the fact that the partitions actually enable us to understand the amount of data being processed beforehand is a huge advantage. So we can use partitions and have a good understanding of how much data a query is going to process and how much a query is going to cost. In the example of searching for data from 2019, we actually have 0 bytes since there's no data, and so that was an entirely free query. Now, what's more is that we could use the where clause and clustering to even further refine our query. For example, we could say where the system equals system C. Unfortunately, we don't get information before the query about how much this is filtered down the amount of data that needs to be analyzed. However, we are actually decreasing costs and increasing performance when we do this approach, and as you can see from the incredible elapsed time and slot time consumed, this is an incredibly lean query compared to when we were searching all the data or even when we were just using that year-based where clause. So, as you can probably tell, if you need some really fine-grained granularity, the clustering is a little bit more flexible, especially if you need to use multiple columns in your filters or aggregations. But the partitioning is really nice and has that advantage of providing information before we run the query about how much data is going to be processed. We should also note that this is not just for filtering with where clauses, but also aggregations. So, for example, we could count the number of records by year, and as before, we're going to have some nice performance improvements as well as some cost improvements. We hope that this quick introduction gave you a good understanding of clustering and partitioning in BigQuery. We'll watch the comments section for any questions and want to thank you for watching.